Hello everyone, welcome to my channel. Here I solve the LeetCode problems and preparing to the code interview. Today I try to find the solution of the most popular problems for the code interview. You can meet it in the code interview in such companies like Facebook, Google, Amazon, etc. The problem is quite simple, but it has an interesting, not trivial solution. The problem is number 1 to sum. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's see the examples. In the first example, we have a list of two elements, 2, 7, 11, and 15, and target number is 9. You can see the solution is first two numbers, 2 and 7. Their sum is 9. How we can find the solution for any kind of lists? First solution is quite simple and straightforward. We can use two loops, one outer and one inner loop. In outer loop, we will go through all items from 0 index to last index, and for that numbers we will check all items right from it. So we will start from index 0, it's number 2, and we will check numbers 7, 11, and 15. If is the sum of number 2 and one of the numbers right from it, and the sum is equals to target number, we will return two indices, one from outer loop and one from inner loop. Let's do it. For outer loop, for I in range from 0 to len nums -1. We need use -1 here because we will check current number and all numbers right from it. So we need at least one item to the right. For inner loop, we use for j in range from I plus 1, so it's at least one item to the right to the last item, so it's length nums, and check the sum. It's nums I plus nums j equals to target, and return indices. That's it. It's quite simple. Let's check the tests. All tests passed. Let's try to submit it. It works, but let's check the execution time. You can see it's 2.5 seconds. It's quite long, and if you see the solution, it's two inner loops. So the algorithmic complexity is quadratic. So for each n items, we need to check n square combination of two numbers. We can improve it using interesting solution. Instead of check all numbers in two inner loops, we can use one loop and save current number and index in some dictionary, and if dictionary is empty, we just save it, and in the next iteration we calculate the remainder, and if the remainder is in the dictionary, we could return the answer, and otherwise we add current number in the dictionary. So we need to create a dictionary, for instance the D, and we need a for loop. In this case we need index and number, so we use function enumerate nums. Function enumerate return a pair of index and value of lists. And now we need to calculate remainder. It's target minus current num. If with remainder in a dictionary, we can return the answer, and the answer is current index and the value from the dictionary. So D dictionary, D reminder. Otherwise we will update dictionary set key equals to num and value is I. So that's it, and let's check the tests. Test passed. Let's submit it. Before submit, let's see one more time on the previous execution time. It was about 2.5 seconds, and let's check and compare it to the current solution. You see, now we have 56 milliseconds. It's much faster, and you can see we have only one for loop, and so algorithmic complexity now is linear. So for the list of n elements, we need to check and do n compares instead of n square compares. It's much faster. That's it. Thanks for watching. See you tomorrow. Bye.